and I am the network administrator for St. Martin's University. Um, I've been taking classes in pursuit of a master's degree, and I've been taking this data visualization class. And so this is my final project for the data visualization class. And in my role as a network administrator, I have access to various pieces of equipment that generate different log files and things. And so I'm able to pull data from that, and we'll use that in a as far as those visualizations we go. So without further ado, let me give you my presentation. So let me share my screen here. And so, oops, I need to refresh my page, get rid of that. Okay, the data visualization final project. So this is our network overview for St. Martin's University. Just wanted to give you guys an idea of where things are coming from. So here's a student, staff, faculty, servers. Everything's connected to a core switch and router, and that goes out to the internet. And between us and the internet is this Palo Alto firewall. And it is a next generation firewall, they call it. And it will process and look at every single piece of data that comes across it, from either inbound or outbound from the internet. And we do about it looks at about 3 terabytes of data every day. And so for it to log all of that data, I mean, that would fill up a hard drive very, very quickly. So instead of doing that, what it does is it will keep track of a stream of data between you and another server, or between a server and us, that type of thing. And so then it basically just logs, yes, yeah, somebody here went to somebody out there, and what type of traffic it was, and whether or not it was a bad or good, or whatever it was, and what kind of action did it do? Did it just drop the traffic? Did it reset it? Did it did it allow it? Did it just alert something? That type of thing. So anyway, so that doesn't really tell you much as far as our data visualizations, but what I did is I was able to pull data from this firewall and put it into a log server. And then the log server is able to, I can extract a CSV file from it. So that's what I did. For April of 2022, I pulled a data set off that firewall, and it's got very detailed information about security threats, and it's very valuable for security threat assessment and response. We can look at and see if there's tweaks that we can make to the firewall to increase our security and things like that. We're not the FBI or the NSA, so we're not trying to like track down cyber criminals or anything like that, but we definitely do want to take a look and see what's there, and just to make sure things are being safely used on the internet. So because we want people to have a safe experience on the internet, and so we filter out all the malware and spyware, hacking attempts, viruses, things like that. So but I'm going to repurpose this data set that I pulled in April to teach you guys how to use 2 different plot diagrams that can be created in RStudio. These are the donut plot and the heat map. And yeah, I thought that this data would be interesting for you guys to look at for doing different things. So in order to set this up, we're going to do the same charts, use the same setup. So we're going to use ggplot2. We're going to use Varitus for our color palette. We're going to use dplyr for manipulating the data, and we're going to use tidyverse so that we can import CSV files. And when you do all these libraries, it gives you this information. And then finally, this threat raw down here at the bottom, this is where we read in the CSV file. change the timestamp characters into timestamp into characters. Excuse me. All right, so these are just the messages you get when you import all that stuff. So, okay, whoops, too fast, too far. Question 1. What countries are attacked SMU the most? So, and then use a donut plot to answer the question. Filter the data set for only the critical severity threats, and then use the Veritas Turbo color palette. It seems to work the best for this particular question. So I'm going to give you some time to work on it yourself. And when you, so pause the video, and then when you're done, unpause it and we'll continue. All right, so we're back. Let's take a look at the answer. So, oops, man, this thing is touchy. All right, so threats. We made a new data set called threats based off the threat raw, and then we're going to filter it with the critical severities. We're going to remove any blank lines, and we're going to select the source country. That's all we're really interested in, is the source country. Then we're going to count those countries by creating a new data set called threat count. And then we want to set a size for our donut. And then we want to include that size into that data set. Then if you notice on our ggplot here, there is no geom donut for ggplot2. So instead, we're going to use a geom call, which is for like a column chart. And we're going to take those columns and bend them around a polar coordinate. So we're using coord polar to kind of manipulate the that chart. Then we're going to fill it with Veritas Turbo, and then give you the H size of the donut form. And then, so let's scroll down here and see what the actual chart looks like, and the data that pulls up. So as you can see here, we've got a light blue, really large section. Looks like around 2,000 in a count. And then we have a green section, about 1,000, and an orange section that's a little less. So, and then a whole bunch of other little ones. So you can see that there's like 40 countries here that it's seen for the month of April. But the largest, to answer the question, the largest would be China. So that was this color here. But it's a little difficult to see, doesn't really give you very good information as far as numbering and that type of thing. So just like any other pie chart, it's a little hard to read sometimes. So, but let's take a look and see what else we can do. So question 2, what's the largest threat seen coming from China? So what we want to do is we want to filter, refine the filter to include only China threats, and then use a donut chart to display the threat IDs that came from China, and use the Turbo Veritas palette. So, yeah, let me give you a few minutes to work on that. Yeah, so you can pause the video, and then when you're done, come back. All right, so we're back, and so here's the answer. So we're going to do both the critical threats as well as the source country of China. And so it's basically the same filter, except we're adding that, and then we're selecting the threat ID, not the country. So we're not really interested in the country anymore. So then threat ID is we have the count of that threat ID, and then basically the same code for the ggplot, except we have a threat ID for the fill instead of for the country. And then, so let's scroll back down. And so there, we have all the different threat IDs coming from China. We have a big yellow area. That's the Realtek Jungle SDK remote code execution vulnerability. Then we have a whole bunch of other remote code execution vulnerabilities in here, as well as the Trojan coin miner command and control traffic. That's interesting. And then we have the Win32 Conficker C, which is a virus. But you can see all of that is like minuscule compared to the Realtek. And what Realtek Jungle SDK remote code execution vulnerability, if you go and look that up on the internet, Realtek is an audio driver for your Windows computer. And in certain versions of that Realtek driver, um, it allowed unauthorized users to execute code on it and remotely. And so that basically means that somebody can take over your computer with that execution vulnerability. These are all, again, severe threats. These are all, critical threats, and they're all blocked by the firewall automatically. So you don't really have to worry about them too much, but it is interesting to see what we get hit with. Um, uh, but in order for this to actually have worked, your computer, you'd have to run that exact version that they're looking for. You would have to also be exposed to the internet and also not have a firewall in between. So it's a good thing that we update all our systems on a regular basis. We also recommend that you guys update all your systems as well, your own personal devices, because the more you update it, the more secure it is. And then in addition to that, if for some reason there is a vulnerability or something found, the firewall will handle it as well. So, all right. Now, let's answer another question. What's a better graphic that we can use to display the results? So in our case, a heat map is a better graphic that we can use because we can use both the source country and threat ID values in one chart and be able to see whatever we need to see. And we can also answer other questions in addition to that. So it's a better graphic. So, and use the Veritas standard palette. So pause the video, and then when you come work on it yourself, and then come back. So go ahead and pause the video. All right, so we're back, and let's see the answer here. So we're going to filter for the critical threats, but in this case, we're going to select two values. So we're not just going to select only one. We got the source country and threat ID, and we're also going to count the source country and threat ID and put them all into one big data set, or all in one data set. It's not really big because the threat raw is actually bigger. But then we're going to do a ggplot, and you can see it's a geom tile. Yeah, so there's no geom heat map either. There's no geom donut. There's no geom heat map. So we're using geom tile instead, and put the X value as the source country and the Y value as the threat ID. And then there are Veritas, the scale filter Veritas is temperature, they call it. And it's basically the standard. And then we're going to angle the X words by 90 degrees so that you can read them because there's a lot. Okay, so you can see under threat ID, there's a whole bunch. And this is all of the threat IDs in that data set for the month. And then this is all the countries in that data set for the month. And they are all charted out into a heat map. And these are all colored by the count that there's in there. And so when it's yellow, it's over 1,000. And that's this one here, which you can see is the Realtek remote code execution vulnerability. And if we come down on our chart, we can see that it goes to China, which is what we saw before on the donut charts. But this one's much easier to see and much easier to find. In addition to that, we can say, well, what are number 2 and number 3? Well, we have number 2 and number 3 right here. They happen to also be Realtek code execution vulnerabilities. Um, and if we scroll down here, looks like this of is where it's at. So let's scroll down further and find out what that is. So that's Iran Islamic Republic of. So it's the Iranians is number 2. And then number 3, it looks like the Netherlands here is our number 3. So if you notice on those donut charts, though, um, pretty much the yellow one was the biggest by far. It's like overpowering everything else. So everything else on here is kind of a purple color, and they're very small onesies, twosies type things. So in order to make these differentiable, we'd have to filter out the larger data on here and remove these basically, and then redo the chart and see where these are at and who's got the most, that type of thing. So, but again, these are all kind of, like I said, 1 or 2 or 3 type of threats. So, but there's a lot. You can see definitely there's all kinds of different things. And you can see what country they came from instantly. So like the Bahamas, yeah, they're looking for a HIK vision camera command injection vulnerability. So I guess they're looking for cameras exposed to the internet, and then they can inject code into that and uh, take over the camera, I guess. The Bahamians are concerned about that, or actually the Belizeans, not the Bahamians. Sorry, my bad. All right. So anyway, so that's the heat map. That's how you create one. Let's take a look at another question though, using a heat map. So because we can look at more than just what you see here. This isn't the only thing you can ask with this data set. The question 4, what applications were in use for SMU traffic, and were they blocked or not? And use the application and action values to create a heat map, and use the Veritas standard palette. So again, pause the video here, and when you come back, we'll look at the answer. Okay, so you're back, and this is the answer. So we took out the filter for the severity, so we're looking at everything, and we're looking at all the applications and all the actions. The reason I took out the severity is because the critical ones, we already know that they're all going to be filtered out. That's that's just an automatic. So let's take a look and see what's not filtered out too. So we're going to take a look at everything. So, but we only are interested in the action and application fields in the data. So, and then of course the count form. And then we create the heat map accordingly with the application for the X and the Y for the action, or yeah, Y for the action. So let's look at the results. So in the action column, we have alert, which means it's allowed, but we still are logging it and alerting people about it. Then we have drop, which means they just drop the traffic. They don't inform anybody. It's just dead. Then they reset both, which means they send messages both to the server and the client saying, hey, we're blocking you. This has been identified as bad. And then they also have reset server, which is just, sending a message to the server, but not the client. And then sinkhole, which is basically we've identified this as a bad DNS traffic, and we're going to take this DNS URL and just do nothing with it. All right. And then down at the bottom, we have all the different applications. So apt-get, Disney Plus, DNS, Flash, FTP, Google, IMAP, LDAP, Limelight, SMB, Microsoft Exchange, RDP, Outlook, PlayStation, SIP, SMTP, SSL, Telnet, unknown TCP, unknown UDP, Voodoo, web browsing, and WebDAV. So interesting they didn't have you know, some other things on here, but these are all just in the threat log. So this is identified threats that may or may not be actual threats. So, and of these, it looks like we have a big yellow, that's unknown UDP. So that's going to be a lot. That's basically traffic that it couldn't identify, but it's alerting on it. Usually malformed or non-compliant network requests and things like that. And then SIP, we're dropping a lot of SIP traffic because there's a vulnerability that we've been scanned for numerous times, and they just won't stop. So I put in a rule to just drop all that traffic. It's called a SIP vicious scanner, and I just drop it now. And then the other traffic that we have here, we've got SSL, which SSL is encrypted traffic, which I can't see on the inside without decrypting it. And we don't decrypt traffic on ours. We could possibly, but it's too much of a risk. So it's an invasion of privacy, and as well as you don't get a whole lot of benefit for going through a lot of headache on that. So we just don't decrypt at all. So that's SSL. And then the next one up is DNS, it looks like, which is anytime you go out to the internet, you're going to do a DNS lookup, do a domain name system lookup. So that's going to be pretty high on the list always. So yeah, that's how you create another type of heat map and another analysis that we can do. So that's kind of the end of my presentation. So just remember, you can do a geom tile and a geom call for different. You can redo the different types of graphics that ggplot has to make different, graph types. So, all right. Well, this is the end of my presentation. If you have any questions, I'll answer them online in an email or whatever. And so, yeah, we'll see you later.